Okay, we'll start with the Scala. Function creations we have seen so far, right? How to create a function, how to use those functions, what logic will be there, how syntactically it will be defined, right? Now, today we'll see some default argument concept, okay? And block of expressions, already we have seen how we can apply block of expressions like using if-else condition within the variable, like ternary operator. Okay, I could refer it as ternary operator. Now here I'll say well, not well, def for define, and I'll create a function, let's say greet function, or to create uh, or to create a greet function. In this greet, I'll take a variable as their name. So I'll say name, and this is a string column. So I'll give their data type as string. So name is argument, a string is a data type. Then second, I will give name colon a string, and second would be this. Second would be, let's say, I'll take as message. Okay, I'll take as message, and this message is a string that we know, and we'll give a value also for this message. We'll say good morning. Okay, we'll say good morning, and then I will use this both in my println statement, which is the body of this function. In println, I will write name. I'll write name, comma, message. I'll write name, comma, message. This is the function body, and function will return, by the way, it will take a string by default. I'll give this function as a string also. What is happening? Name and string, it says type mismatch found unit. Okay. Since I'm using println statement, so let's keep this like this. Okay. Now, actually, I should have used plus sign here because I'm trying to concatenate this. Okay. I will try to concatenate these messages, and now I will pass. Now I'll pass two value in greet. I'll say greet. You'll see the error first. Greet name. I'll say hello Billy. Hello Billy. Good morning. So when I'm passing this value as hello Billy, first we'll try to understand what we are doing here in this line number 1. This is my define. Greet is my function name, which could be any logical name. You can write anything else apart from greet. There is do not focus on the name which I'm writing. This name could be anything. Okay, so you can write anything here. You can write anything in this argument. Only you have to focus what is the syntax to define the function, that's def. Then argument, any one argument which can have any name. Second argument, their data type. First argument, data type, means what value will it take when I pass any argument's value. Second argument is this, which has a value of a string. And in second argument, I'm passing gm in the double quote, which means this is what? This is your default argument. This is your default argument. I'm calling as a default argument because I'm writing this value of message good morning in the function definition itself. When I'm creating the function, while creating the function itself, I define what will be the value of msg, which is a message. Okay, that's why I'm calling it a default argument. And in this println, by the way, I should read this line. In this println, I'm writing this. I'm saying print the value of name and message, and plus means concatenate this to value. concatenate this two value, and hence you can see the output, hello Billy, good morning. This is concatenated. Name, this is name result, and this is the message result. But default argument actually works only in this case. What they say, I'll write few rules. What they say, default argument should be defined or must be defined within function. That's one. So obviously within function it will define, and it must be a last argument. It must be a last argument. Okay, it's like that. I have two argument, name and message, and this is the default argument, so it's a last argument. If I read this greet, this is the second argument, and I have total 1 and 2, so second is the last argument, right? If I write the same thing here in place of first argument, what will happen? We'll try to challenge this, and we should try this often to learn programming better. We will say greet, okay? We'll say greet. No, both are okay. Both are fine. Since the message function is created, means both. When I print this, what will happen? Instead of this space, you'll get comma. If you're getting me, instead of this space, if you're using this, you'll get comma. That's it. It will concatenate, but string to string can be concatenated with the comma also. Just the way I have written. After that, yeah, what I'm saying here, so I'm changing my position, my argument position, and here I'm saying MSG is, I'll write the same thing, only my argument will replace by their positions. Okay, so MSG string, I'm saying this is a string, and now I'll want to call the same value as GM. Let's say this is good evening. Okay, I'll create a first, I need to redefine this. This is good evening, and then I'll give a name colon string is equal to, you can, let's say you try this time. Function body can be anything. Okay, I can keep name also, I can keep message also, up to me how I'm defining. Now your default argument is in first place, so you are challenging this line. You are saying default argument must be defined. Your Scala says this, but you are saying no, I want to create this. And then when you're calling your function, you said the same thing, greet hello Billy. What will happen? It throws you exception. I will tell you why this exception is coming. This exception is coming due to the compiler. Okay, due to the compiler, because this MSG is a first argument. Now forget about this line. Now focus on this line. This I have redefined. In MSG I have given one default value, and second argument is name, and then I'm saying name in message. When I'm giving this value, okay, when I'm calling greet function and giving this value, hello Billy, then how you know that you're thinking internally this hello Billy is for name, and message will automatically taken by this function, or taken from this function. So this message will be taken by this function, and my Billy will automatically map with this. That's what you're thinking when you're calling it. But that is not the case. Your compiler will always map. This compiler job is always one by one. So this compiler will write this hello Billy to message. This compiler will write this hello Billy to message, and it will miss out for name since there is no second value for this one. That is the reason they're giving you clear error, not enough argument for method greet. They're saying the argument second is missing, because they're not magician, right? They're not able to understand this hello Billy will go to name or something. So how can I handle this? I can definitely write this. I can definitely challenge the Scala point, but I will have to handle like this. I'll have to say, message is already there. So why don't you write specifically name here? If you do now, it will work perfectly, right? So you can map it. First, Scala says this is the good practice. You should always keep default argument at the last place. But however, by mistaken, you define them at first argument. So you have this handling point. You can refer their name. Can I override? So can I override the default value? This good evening, can I write it as good night? Can I say hello Billy, good night? So definitely I can say that. Hello name is this and message equal to this. You can change the position, okay? Within this bracket, excuse me, you can write this message at first place, this name at second place. You can interchange them, no problem at all. And this will be good night, good night. When you print this, so your good evening is overwritten. This is what we call, it's overwritten. It's overwritten. There's two other things you're going to see. Overriding. You're going to see overriding is another thing. Then you'll see overloading. Overloading. This two things will come. We'll see this two parts in polymorphism when we start our OOPS programming. So we'll see this in the polymorphism. Currently, let's focus on the overwritten point. So overwritten is saying I'll override this value. That's what about your functions. And by the way, you can create anything here. Let me create a function for factorial. So using simple for loop or if else condition, I can do that. I can say diff facto. So I'm creating a function for factorial, which is a kind of recursive function. Factorial, Fibonacci. We have solved all this basic programs in interviews of starting college days, right? And in college days also, how Fibonacci will work, how factorial will work, how other series will. There are 10 different series. So de facto, I'm trying to create a factorial, and first I will build. I'll not directly go to my facto and start writing something. I'll think how factorial works. So I'll take one rough book and I'll try to build my approach. Always think there. How can you build it? Maybe you can Google it up also, but don't just copy and write somewhere, because that's not the good learning stage then. First approach is, what is a factorial? What factorial does? I'll think this. I know this factorial is calling it itself function, its own function. Factorial is calling its own function again and again, because if I create a mathematical approach, I'll say, let me calculate 5 factorial. I'll say, okay, let me calculate 5 factorial. So forget about the Python or forget about the Scala and other thing. Just think this way. If you want to calculate 5 factorial, then how this works? This goes 5 into 4 into 3 into 2 into 1. This is what it derive. If I type this, it do not give me this. Rather, I just get the output as 5, 4, 24, 20, 60, 120. This is 120. We straightforward get the answer. If I type 5 factorial, we get the answer directly. Nobody will explain me this is happening. Okay, this logic is not there, because if they're retreading the logic also, maybe the compilation will take time. So this is how internally it's built. Now I want to create my function. Can I call that's a user defined function? So every function has a 2 type. Every function has a 2 type. First one function is an inbuilt function. You're using this function, which are there already and given by Scala. Second, you are using user-defined functions. I rely personally more on the second, user-defined function, because first function you can just Google it up and get it. This is like retofine. We can remember this, but this is based on this logic. If this is good, I always say you can get this also. You can build your own function. Doesn't matter you remember them or not. Just logic is important. So 120 is the output. And now I think what they're doing, actually they're one argument only, right? If I write this is n factorial, this is n factorial, I'm just trying to relate this now, okay? If I write this is n factorial, so what I'm doing here, I'm doing n into n minus 1 into n minus 2 into n minus 3 into so on till n minus 1 plus n. That's what I'm doing, right? N minus 1, sorry, n plus 1 minus n. I'm sorry, this is n plus 1 minus n. This is what it is going till last. So n cancels out and it fixes to n, to 1. Now I want to write this logic in my function. I want to replicate this logic in my function. So I'll build here de facto and and it needs just one argument. I'll take n, and to handle the big number, I'll say big integer, which is kind of long, 8 byte. I can use long also, no problem. You can use long also, you can use big integer also. I'll choose big integer is equal to, now I can use for loop, I can use if else condition, I can use if nested if else condition, I can use this logic, basic conditional expression to write the facto. And logic would be this. So I'll say if n, okay, if n is equal to 0, so 1, because we know 0 factorial is always a 1. Okay, 0 factorial is not 0. 0 factorial is 1 and factorial is never in negative. So if n is 0, it is 1. I handle the 0 part and then I'll say else n into if it is, let's say 1, 2 or 3, then it goes to else condition directly and says 1 into function is a recursive and recursive function calls its own function, which is facto. Facto is the function, and there I'll write n minus 1. That's what is happening every time. 5 minus 1, 5 minus 2, 5 minus 3. So every time number will decrease and start doing this. And I think this is good. But when I type this, it gives me some kind of error. And this error is what? If I read this error, it says recursive method facto needs result type. Okay, it says me, it clearly gives me error. This is more important to debug it, because you cannot write 100% running code. You should know how to debug it, how to read the error and solve it. Recursive method facto needs a result type, which means if I see this error, one thing is very clear, that this is a recursive function, right? I'm trying to build a recursive function, and we have written in our first class the point that any recursive function in Scala needs a return type. If it is a recursive function in Scala, it needs a return type. That's what it means. So return type means I will be defining something here. This is missing. This function return type is missing. So I will have to write some return type here, and that some return type name is big integer, obviously. If my argument is big integer, my return type will also be big integer. This is good now. Let's try it. So first you're building, then you're testing it. If it is 0, it's 1, perfect. If it is 2, it's 2, good. If it is 3, it's 3, that's good also. If it is 5, it's 5, 120, getting good answer. If it is 6, it is 720. If it is minus 9, it gives me error because we have not defined. This is like my, I think it ends with some some different error, which is okay because I did not define any logic for minus. Okay, that's the reason they are giving me that error. And I'm not defining any logic for minus because there is no minus factorial. Now, how this is working in the logic? You said if n is equal to 0. This is like an equality operator. If I break this code, and read it, okay, let me write it again. Def, I'm writing facto, I'm giving n, which is a big integer. This is also the same data type, which is a big integer, is equal to, I'm writing one condition. If n is equal to 0, so I'm using here an equality operator. I'm saying if this is 0, give me 1, else. And this is a simple if else condition, else n into factor n minus 1. You're calling your own function. And then how this is working, you pass 6. Okay, let's read the loop. Let's read the code here. You pass 6 here. Now 6 is checking for first condition, because always it checks the first condition. Is 6 equal to 0? This condition is failed because 6 is not equal to 0. Then it goes to else and say, okay, 6 into, immediately it will pick up 6 in place of n into facto n minus 1. It is going back to facto and calling their value. N minus 1 is 5, so factor 5 will be called up. This n is 5 now. Okay, since this is 5, I'll not write directly 5 here. This is 5. Now it will check again. This is the first condition checking. Second condition it will check. I'll write their indexes starting from 1. Okay, index starts from 0 by the way, but this is just a notation. This is 5 is equal to 0. Is this condition true now? This is also fail because 5 is not equal to 0. Again, it will go to else loop. Again, in place of this n, 5 will be printed. Again, factor n minus 1. 5 minus 1, 4. 5 minus 1, 4. And this factor is called over. So factor n, factor 4. Again, it is checking. 4 is equal to 0. This is false again. Again, it will multiply 4. Then again, 4 minus 1, 3. And 3. Is 3 equal to 0? Since this is the beginning, I'm just breaking up the code for you. Later on, we'll go little fast. So try to understand this concepts now. 3 and 3 is so 3 is passed over here. 3 minus 1, which is 2. To again go here to body. 2 is equal to 0. I'm checking 5th time. 2 is equal to 0. This is also false. And then it again goes to else and runs this 2 into factor 2 minus 1, which is 1. And here it goes 1. Again, this condition is failed, which is 6th condition. It says 1 is not equal to 0. This is fail. And then it multiplies 1. Okay. So 1, it is there. And now it says factor 1 minus 1. Right? It says 1 into facto. Internally, what is happening in compiler? 1 minus 1 is 0. And then as soon as this 0 reaches to there, facto 0, it checks the if condition and finds 0 is equal to 0. The 7th time, they're actually not giving you output of this, but they're checking it. 0 is equal to 0, and this condition is true. The if condition is true, and this condition is true. So the return is 1. They'll multiply. Again. Once again, they'll not multiply. This is the output. Your loop is exit after this. So compiler is running actually 7 times. Recursive function is, that's why they're not recommended most of the time. They takes memory. They use more CPU, because currently I'm checking for 6. Let's say I'm checking for 60. My CPU is captured, occupied till the last number is not executed. Okay, they do not release the memory until and unless they don't complete this calculation for all the element. After complete elements, then only they will release it. So if it's a bigger number, it's sometime creates the havoc in your programs, okay, and undefined errors and issues, which is difficult to debug. So that's about factorial. Now, function, we know how to create. We know how to create recursive kind of functions, why they're required. How can we create a default argument? Now we'll talk about uh, different functions, like advanced concept of functions, and that is this four things. Advanced concept of function starts with higher order functions. Higher order function. So you'll find Scala is working as magicians. They actually handle functions smoothly. One function can call another function, can call another function. One function can be referred as another function argument. One function can assign to a variable. One function can assign to any variable println statement also. So it's like I can play with the functions a lot in a Scala, because Scala is a pure object oriented language. It's unlike Java. Java is not pure object oriented. This is a pure object oriented, same as Python. And Scala is much robust when we want to use their functions. That is the reason we call them that they are first class citizens. The functions are first class citizens, which means I can use these functions anywhere. Let's learn this higher order functions and then try to create, based on this higher order functions, we'll try to create generic functions. Generic functions. And after generic functions, we'll try to understand lambda functions. So this is three different function we're going to see today. Lambda function is anonymous kind of functions. Okay, so more about lambda we'll see after getting this point number 1 and point number 2. Point number one says create two functions. So let me create function for addition 8, and then I'll say x colon integer, y colon integer, and this is x plus y. A simple tiny approach to create one function. Another function I'll create as, let's say, multi. I want to multiply x and y. I'll keep the same argument as same integer, and I'll just change the function body as x into y. So this two function is created, and now I want to create a higher order functions. And using that function, I want to call these two functions. So this is I'll define it first, then I will explain you. And this is little big HF, and I'll say f colon function notations. What is the return type is integer, comma integer is transforming integer. So integer, op1, one variable is integer, op2 second variable is also integer, and this function is calling this op1 and op2. Don't worry, I'll explain you every bit of it, what I'm trying to write. Perfect. So HOF is my higher order functions. Okay. This HOF is just a name, HOF. You can write anything else. What is this F? We'll first understand this too. This is very easy. We know that we're using add to argument. Both are integer, and we are doing addition and multiplication. Now the third line, HOF F. What is this F? F is just a notation. You could use any letter from A to Z, anything, F, A, B, C, D, anything. Okay, so F is just notation for pointing out the function. This F is actually pointing this functions, either add or multiply. Okay, this F is pointing the function and defining this. This is actually means your function name. You can assume it as add or multi. Okay, colon function colon, you have two different arguments, integer and integer. Okay, can you read this comma section? So within this function, if you read this whole part, you'll find this f is actually a function of 8, which is trying to point this add and multi And this integer is actually this integer and this integer. And here also I have integer and integer. So this two integer is of your two different arguments. What is their return type? This two integer is your arguments data type, which is integer. Okay, and that is the reason one limitation you can remember right here, that if you're creating a higher order functions, your both the function must have the same data type, integer. If this is integer, this is double, there could be issue. I'll tell you how to handle that also, but currently this is the limitation in higher order functions type number one, that if you're passing x and y as two argument, you can only pass integer here. Okay, so if you have already given integer and xy, you can only pass integer here. You cannot even take more number of argument here. You can't say x, y, z. You can't take three argument here. The same number of argument you have to satisfy. So argument is required, because if I'm creating a kind of this function, this 2 is representing this integer is coming from x and y, and x and y both are integer. If this is integer, this is double float, then how could I write this? That's a problem. If this is xy, this is xyz, there is, let's assume there is another argument. How can you write this? So this is why we have two limitations as of now. Okay, this limitations I will take over. Currently I have two limitation, that I can only pass 2 times integer because there are 2 times integer written. Okay, that's one. Second is this sign. This is the sign of transformation. In Scala, whenever you find this sign now, you remember this is for transformation. This is for transformation. Okay, and this 2 is returning what? This function is also returning you integer, and this function is also returning you integer. Both functions are returning integer. That's the reason I am writing here integer. So hopefully this function is derived now. And what is OP1 and OP2? OP1 is argument of x, because obviously when you call this HOF, you need to pass one value. So this OP1 is actually mapping with x, and this OP2 is trying to map with y, as in first value and second value when you call this. And this is how the function body is looking. When I call function, and I'll pass their OP1 and OP2 with a comma separation, because there is a comma separation here. Let's call this function HOF. So all the limitation which I talked about, I will try to solve all the exceptions. Okay, HOF. Now in this function, now the mapping will work correctly. In this place of f, which is the first f colon integer transformation integer, the highlighted area, this is actually your function area. This OP1 and OP2, then just three things we have. This function f thing you will replace by, let's say 8. So this ADD is actually mapping with this f, isn't it, from function. And then you will pass comma. You can obviously use bracket also if you want, up to you. I can use comma directly. 8 comma, and now you'll pass two value. Let's say 7 comma 9, but strictly integer. I cannot pass double or float. It's strictly integer value. 7 is actually mapped with OP1 and 9 is mapped with OP2. So what this function is doing, this is the explanation of function calling function. Hello. Suminda, can you hear me? Actually, the electricity went off, and reconnected with phone. Let me know once you can hear me. I think Ansika also disconnected. We'll wait for 2-3 minutes if she can connect. Let's start then. Screen is visible, right? Thanks. We'll just wait for another minute and then we'll continue. Okay, so we'll continue from here now. Okay. This is the how mapping is working, and when I click on enter, I can see ADD is function 7 and 9 is aiding. If I use multi here instead of ADD, I use multi here, you know what will happen? So this will multiply it because it will go to this multiplication body. What the function of multi is doing, the function of multi is multiplying each argument by their second argument. So this is how their output will come. This is about higher order functions, but this is not fitting with two cases. First case, I am hard coding their data type. So it is only designed, this function is only designed for integer. And that too, it can only take two arguments. Okay, can I handle it? Can I say HOF integer, and instead of writing this instead of writing this ADD and multi, can I directly write this? Can I directly write this thing and this thing? So assume that this is not there. Assume this function is not there. Okay, this function is not there. And I have directly created this. I've directly created HF with assumption of this. So no need to create ADD and multifunction. You can actually directly write the function body here. You can say this. Instead of calling ADD, you can say x comma y transforming x plus y. You'll get the same output. Even you can do multiplication, division, addition, subtraction, all these things you can do. This is what is known as a lambda. This is a lambda function. Whatever I write inside this is a lambda function. We can call it's an anonymous function. It's an anonymous function. So I'll explain you what is lambda and what is an anonymous function. I assume that this function is not there. I assume that I have not created ADD and multi. I started directly from this HOF, okay? And I have given this function body. This will take two integer, will return one integer of this function. OP1 is one variable, OP2 is another variable. Then I will call this function. Then I will pass two argument. Now, instead of using ADD or multi, subtraction was even not there. What is the benefit? I can do that, that's one thing. How is another part, but what is the benefit? If I use this thing, what is the benefit? Because when I define a function, like ADD or multiplication, what happens in your CPU, in your RAM space, in your memory, okay, which is your RAM space, in your memory, which is a volatile location. Volatile is nothing but RAM only. So when you call add or multiplication, anything, if you use this diff, and diff here, and when you create actually some function, it will take some space in memory for sure, right? It will not go anywhere in the air. It will store somewhere in this machine only, right? If I'm writing this ADD and multiplication and given two argument, which is x and y, and both are integer and integer for both the case, so this will store 8 byte. This ADD will take 8 byte space because 4 byte in memory, and similarly this multi will also take 8 byte space in memory if I'm defining it. And whenever I'm calling this ADD, two things are happening actually. Whenever you write x equal to 10, okay, whenever you write x equal to 10, so in Scala terms we call well x equal to 10. We're writing this, okay, just you're using this single line. Two things happening. First thing, they will take some space in memory. They will take some byte of it, which is a 4 byte, because this is currently integer. So this x will take in memory 4 byte. This is what is happening. And second is they're computing this 10 in CPU. So 4 byte request will go to CPU, and then immediately it will compute and give you the answer as 4. So two things are happening. First, they refer to memory, then second, they pass to CPU. And that's the reason we learn about lazy, that do not call every time to CPU. When required to CPU, then only call. So the lazy actually taught us that point. Okay. Now, what is the use of Lambda? Lazy is one computation optimization area. Lambda is another area. So Lambda is nowadays used in many places. In fact, in Java 1.8 also they have brought it. Scala, Python is there. X comma y, x plus y, I'm not writing any 8 function or multiplication function. So first thing, in memory, this 8 byte space is not taken by any function. This 8 byte space is free. Now you must be thinking why we're struggling for just small 8 byte space. It's not about 8 byte. Today it is 8 byte. Tomorrow, if you're getting thousands of functions, it may reach to 80 GB also. Your code can be, your jar file can be sometime 3 GB, 4 GB also, right? So you have to optimize as much as you can. That's what is the main thing. Always we programmer write our code in two parts. First, we write the code to prove the point, and second, we optimize it. Always this is the two part whenever any coding part will come. Okay, so currently I'm not talking about the writing, I'm talking about the optimization. Lambda is actually optimizing it. So Lambda is not using any ready-made function. Lambda is calling immediately. Lambda is calling immediately when it is required. And this x and y is what? This x and y is your xy, comma, and this x plus y. This is the operation. This is the function body. This is your expression of xy. I can call many things. This is expression of xy. This is expression of xy. This is expression. This is a kind of binary operation. So binary looks math. If I say in computer language, I'll say this is an associative operation. This is an associative operation. Just like, what is associative operation? You say a plus b is equal to b plus a. You say a into b is equal to b into a. That's what is associative operation. They are associated. Your LHS is associated with RHS. Okay. So Lambda, I think I'm able to tell you the Lambda. So we have solved the first problem, that we just need to write this line. These lines are even not required, and we can pass any operations, but still the problem which I'm facing is not solved. I am bounded with the data type. So I will write this. I'll say, can I use, instead of writing integer, can I use t here? And I'll tell you the significance of this t. When you read a Scala book, or I don't know if you started reading any textbook for Scala, you'll find most of the time the function is created by this t. This t stand for type specific. So T is just a notation. You can use anything in place of T. T is for type is specific. What this T is T explain us. This T says you can pass any data type. Let me keep this one more T here. You can pass any data type while calling this function. Okay, let me write it in English. While calling this HOF function, you may pass or call any data type. Not necessarily we'll be calling this integer. We can call anything, integer, double, float. So the problem is gone. I'm not anymore dependent on integer now. I can pass any data type here. Okay, and let's take example first. Can I create this? Okay, this is created. And can I call this HOF now? So HOF, and I'll say this time, let's say float. I want to multiply to float, and I will use lambda here. I'll use my lambda. So I'm using generic and lambda both. And I want it to multiply, so I'll say a comma b, and this could be anything, a comma b, I comma j, m comma n, x comma y, any letter, a into b, comma, you have to pass some value, 13.008 and 12.9. And yes, if it is a float, we have to use f at last. We get the answer that this is the answer after decimal 4 points. Okay. Now the question is, I'm using float now. Can I pass other family data like integer? Can I pass? So integer we have seen. Let's try something else. Let's say long. Can we pass long? 1300 and 12. So this is multiplication. I'm trying to edit. So yes, I can pass this also. So in single function, I have explained lambda, and I did this with any data type. So lambda and generic, this is like a generic function, more or less. I can write it up. This is the generic function, the type number 2. So type number 3 already we have seen. And now if you're thinking data type is solved, but can you solve for argument also? So I can create any number of arguments here. Currently, when I'm creating this HOF, I'm using T and T. I can use n number of T here. I can use T for first argument, second argument, third argument, fourth argument, fifth argument. It depends on my argument, how many arguments I want to create. So I can type that many times of T. And whenever you pass that many times of T, then when you're calling the function, you have to satisfy all the T. You have to pass some value, okay? This programming language will not compile otherwise. You have to pass for all the arguments. Otherwise, you'll get that exception. Too less argument passed or too many argument passed for these functions. So this is for higher order functions, generic functions, and you're not applying only this T thing for here. T thing you can apply here also. Whenever you are creating a function, you can actually apply this T. Okay. So this is about your higher order functions, generic functions, and lambda functions. Try this out today, and from tomorrow, then we can pick up our topic of array. Let's see array and array buffer. We'll try to understand this two, array and array buffer, tomorrow, and then we'll start the collections after array and array buffer.